These are the notes for Unit 3, Section B. So we're going to be solving linear equations today, and what that essentially means is we're going to find the unknown value, which is the variable, whatever letter that happens to be. And we do that solving by isolating the variable. And in order to isolate that variable, we have to undo the operations that are happening. Now, I'm going to like to use the term inverse as opposed to undo, but inverse is kind of a mathematical way of saying undo whatever operation is being done. So let's look at some common operations and inverses. So to undo addition, we're going to subtract. That is the inverse operation. To undo subtraction, we're going to add. That's the inverse operation. To undo multiplication, the inverse operation would be to divide. And then to undo division, the inverse operation would be multiplication, or to multiply. So generally speaking, and for two-step equations, one and two-step equations, this is going to hold pretty true. We're always going to start by adding or subtracting, so we kind of reverse the order of operations. Then we're going to multiply and or divide. Now, a more general way to think of this is, and this doesn't always work, but this is kind of a fun guideline to go by, is we are really doing the inverse of the order of operations. So I like to think of this as SAD/MEP instead of PEMDAS. So we're going to try to take care of typically addition and subtraction first, then multiplication and division, but remember those are equivalent operations. And then exponents, if I have a variable that has an exponent, I want to get it by itself, or if I have something going on inside of parentheses, I want to isolate those parentheses last. So this doesn't always hold true, but it's a pretty good way of thinking about these things in general. It gives you a path to go if you're kind of stuck. So if we're solving one-step equations, that means one operation is being done, so I have to do the inverse. So for number one, the inverse of 7x would be to divide both sides by 7, and that's the same sign. Negative 21 divided by 7 is negative 3. Here are my variables on the left, but it doesn't really matter. I'm subtracting 23, so the inverse operation would be to add 23 to both sides. So 40 is equal to x is equal to 40, depending on how you want to write it or rewrite it. This one I'm dividing by 4, so I'm going to multiply the left side by 4, which, don't get too fancy there, the only reason you're multiplying is to get rid of the division by 4. So you're not really, you could actually multiply and reduce that rational expression, but there's no reason to do all of that. You're just multiplying both sides by 4. And then here, I'm adding 21, so my inverse operation is going to be subtract 21. And these, you're going to be doing a lot of integer addition and subtraction, so it's probably a good idea just to make sure that you're doing everything correctly here. The nice part about these problems is it's pretty easy to check our solutions. I just plug in our x value. These all happen to be x, but it could be any variable. So we're going to say plug in the x value or variable value. So 7 times negative 3 is negative 21. 17 is equal to 40 minus 23. That's true. 20 divided by 4 is in fact 5, and then 59 plus 21 is 80. So the nice thing is, if you're not sure, especially on multi-step problems, it's a pretty good idea to just go ahead and check your work to make sure that you're on the right track. Let's take a look at the next page. On a two-step problem, if we're generally following that SAD/MEP where we're going in reverse, normally we would think about multiplication and division first, and then we would move on to addition and subtraction, but we are doing the inverse, so we're going to work backward. So in this problem, I need to take care of that plus 19 by subtracting 19 from both sides. So I'm going to get 5x is equal to negative 60. Then the inverse operation there is to divide by 5, so x is going to be equal to negative 12. And again, as we saw previously, we could go ahead and plug in that negative 12. And if we evaluate it, we should find that negative 12 does in fact work. Again, here, I want to take care of the addition or subtraction first. I have subtraction, so the inverse is addition. So that's going to give me 46 is equal to 2x. The inverse of that multiplication of 2 is to divide both sides by 2. So I get 23 is equal to x, or x is equal to 23. Either way, you're just fine. This one I got a couple of things going here. Let's just go ahead and get this negative x squared by itself first. So let's take care of this. And what am I doing to the negative x squared? Well, what I'm doing is I'm dividing by 6, so that means I'm going to multiply both sides by 6. So I get negative x is equal to 18. And that can be read two ways. Sometimes I like to think of this as the opposite of x is equal to 18, which means the answer is negative 18. You could also just divide by negative 1 to change that sign. Either way, what is happening here is a sign change of that number. So x is equal to negative 18. And then here, remember that this is a positive 4. So I'm going to subtract 4 from both sides. So I get negative 9x is equal to negative 36. It might be helpful to actually put that positive 4 there. That positive 4 is implied. But it doesn't look like an actual operation. So that positive sign might be helpful. I'm going to divide both sides by negative 9. So I get x is equal to 4. A negative divided by a negative is a positive. All right, so to solve those multi-step equations now, to solve the two-step equations, we kind of work that order of operations backwards. To solve multi-step equations, well, if we have to distribute, we're going to distribute. And then after we distribute, sometimes we have to combine like terms. Okay, I can't go solving until I can combine all terms that are like. So let's see what that looks like on these examples. So number 1 is a good example of distribution. So I have to do 2x minus 18, not 9. And now I just treat this as a multi-step problem, so I'm going to add 18 to both sides. So I get 2x is equal to 90, x is equal to 45. Okay, and a problem with like terms, well, if you have more than one variable, we're trying to isolate the variable. Well, if I have two variables, I can't very well isolate a variable. So let's see if we can combine these two, and I can. So now I'm going to get 14 is equal to 5x plus 24. Now, you're probably looking at the 14 and the 24 thinking that they're like terms, but they're on opposite sides of the equal sign. So we really want to be careful there. Don't try to do too much in one step here. So let's just look at this as a multi-step problem. Now I'm going to subtract 24 from both sides. So I'm going to get negative 10 is equal to 5x. And I divide both sides by 5 to get x is equal to negative 2. Okay, so those are two variations of problems that you might see. So what I'd like you to do, let's go ahead and pause this video. And after you pause this video, let's work problems 3, 4, 5, and 6. I'll show you my steps and my answers so you can kind of check your work before we move on to the homework. All right, let's see how we did. I'm just going to walk through these problems. I didn't show all the inverse operations, but I'm going to distribute the 3. Then I subtract 30 from both sides. Then I get 6x equals 36. Divide both sides by 6, and that will give me x is equal to 6. Again, you can go ahead and pretty easily check that. When you plug in the 6, you get 6 times 2 is 12, plus 10 is 22. 3 times 22 is, in fact, 66. I'm not going to do that for every problem, but remember that is an option if you're unsure of your work and you don't want to look at a key or you don't have a key available. Here I'm going to combine like terms. Be careful, 4x minus 5x is, in fact, negative x. Add 17 to both sides, so I get negative x is equal to 33, which means x is equal to negative 33. Here I'm going to distribute the 4. Make sure that that 4 gets distributed to both terms, please. And be careful of your sign, so you get 4x minus 4. Add 4 to both sides, divide both sides by 4, and my answer is x equals 8. And finally here, that is a negative 2 that we're distributing, so really be careful with your signs when you distribute there. That's going to change both of those terms to negative terms. So negative 10 minus 2x is equal to 12. I add 10 to both sides, which gives me negative 2x equals 22. Divide both sides by a negative 2, which gives me x is equal to negative 11. All right, so the homework for tonight is going to be Unit 3, worksheet B. Complete all those problems, and don't be afraid to look back in your notes for some of those problems that look similar to the ones, whether it's distribution you're having a tough time with or combining like terms or things like that. Find those examples from your notes. But these examples should be things that you have at least had exposure to or seen before, even if you've struggled with in the past. So good luck on the homework, and don't forget that the homework is Unit 3, Worksheet B. Thanks.